Mentally pumped to go see the third.
I heard the third one's awful.
It doesn't matter if it's. I think what it is. I was asked McLean and Larry went, and basically, it's the in battle. He's like, it's just the in battle the whole time. But the way I see it is they've done it again, like kind of like how Lord of the Rings was, where they're not three independent movies. They're one big movie.
I'm sure I'll enjoy it, but every review I've heard so far has just been, this is garbage.
I think there wasn't a whole lot of plot.
Yeah.
But I mean, I was like, how can you do it? Like, from this part of the story on, you got Thorn's kind of punk.
Mm-hmm.
Everyone argues. Then goblins come, so everyone gets together.
Has Breslaw already given away the Ark and Stone? Did that happen in the last
No.
movie?
The last movie ended with the awakening of Smaug,
Uh-huh.
which I thought was a really weird spot to end the movie.
Yeah.
I thought ending with the death of Smaug would have been the smart place.
Right, well they just wanted to get Smaug in there, A, so you'd see it, but B, to kind of get him out of the way, you know?
Yeah.
And the second movie was kind of pointless, except for, oh, there's this cool dragon.
But I figured they would at least finish off, because it starts with, ended with Smaug flying
Uh-huh.
to Lake Town.
Yeah.
And I was just like, that's so weird. Like, the logical spot would have been like epic battle against Smaug, movie ends,
Uh-huh.
then do. But I was just like, whatever, you guys probably realize I will now pay money to come see this
Right,
movie.
that's the point. That's all they're doing, is they're just finding a way to see Steve come back. It's like how Two Towers had Shelob in it, big spider.
Yeah.
And really should have been Return of the King, or whatever.
But
No.
they did it weird where they picked up. No.
No,
Is it?
Shelob was.
Yeah, it
Yeah.
ended. Didn't the Two
Two
Towers?
Towers ended with Gollum talking about the spider.
Yeah.
Yeah.
And they were leaving. But I feel like Shelob was in Two Towers in the books.
Yes.
There was something
Yes.
backwards with
Mhm.
her.
Mm-hmm.
But you see that what they did it differently, where they just, because there's basically the two stories. They just stopped the two stories in different spots,
Mm-hmm. Yeah.
and then they went. Return of the King. They focused a little bit more on that whole Bilbo thing, or Frodo, because the whole Frodo story is really kind of a back burner.
At that point, yeah, it's also
See-
quite boring.
Yeah,
So walk and hide and walk and hide and get more and more depressed.
yeah.
Yeah.
Because I mean, the main storyline, cool storyline, like.
Yeah, that was so cool how he did that. You know, like, next thing you know, you care more about who's really Gondor than you do about the ring.
So I remember when I read it, I'd be like, "Oh my God, another Frodo section! Can I just skip this and go back?" Because
Yeah,
it
it
would
was
cliffhang you.
painful.
It would always cliffhang you with the Gondor
It
stuff.
was painful. You know, unless Sam is like being freaking Samwise and just being a total hero, you're just like, this is so boring and depressing.
Which I really felt the movies didn't act like. They made Sam seem really whinerish in the movies,
Mhm.
which bothered me. Because in actuality, Sam was.
Well, I mean, they also made the dwarf the funny one and the elf the serious one. You know, like, they got all that backwards.
Yeah.
The elves are like incredibly cheerful and joyful and gay, but they made them all super serious and stone-faced and blah all the time. So the dwarf was the comic relief, and that's just backwards.
Yeah. They do what they want.
They do what they want. Alright, well the question now is, should I start teaching from this point? Or make a separate video of us discussing Lord of the Rings?
I feel like you
Hobbit?
just start teaching from
Start
this
teaching
thing
here.
and then put the whole thing out there.
Okay.
So the first 4 minutes is us talking.
This is gonna be like a 30-minute video then.
It doesn't matter.
Doesn't it? Well, 7.6 is rational exponent. The question is, what is x to the 1/2? If we were in class, I would pause and have you grab your calculator and play with x to the 1/2 and see if you can figure out what it is. But we're not in class, so I'll just tell you. X to the 1/2 means square root of x. So if I had like 4 to the 1/2, that's 2, and 16 to the 1/2 is 4, and 9 to the 1/2 is 3. The reason for that is if you think about x to the 1/2, if I were to square x to the 1/2, We'll have to do 1/2 times 2, which would be x to the first, which is just x. But we already know that the square root of x squared equals x. So really the square root of x is the same as x to the 1/2. And if I had the third root of x, I'm sorry, x to the 1/3 is the third root of x. X to the 1/4 is the fourth root of x. Whatever number is in the denominator of that power fraction is the number that goes on your shelf. So if I had x to the 3/5, this is where things get a little bit interesting. The bottom number goes on the shelf. This number here is my power. So x to the 3/5 is really the fifth root of x to the third. So I can do some calculations here. 27 to the 1/3 is really the third root of 27, which is 3. 27 to the 4/3 is the third root of 27 to the 4th. But I already know that the third root of 27 is 3. So this is really 3 to the 4th. 3, 9, 27, 81, so this is 81. 1,000 to the 5/3 is the third root of 1,000 to the 5th. But the third root of 1,000 is 10, so it's really 10 to the 5th, which is a 1 with 5 zeros. Now, you can calculate these in your calculator. You type in just as it looks. If I want to type in 1,000 to the, in parentheses, that has to be in parentheses, 5/3, I get my 1 with 5 zeros, I get that one. We have radical form and exponential form. Radical form is the one that involves the radicals, obviously. So, the third root of a squared. In exponential form, that's a to the 2/3. The fifth root of x to the 9th is x to the 9/5. And going the direction, if I had a to the 2/7, that's the 7th root of a squared. And if I had 3a to the 5th to the 2/3, it's the third root of 3a to the 5th squared, which I could also call the third root of 9a to the 10th. Because really this is the same as 3 to the 2/3, a to the 10/3. I'll talk about that in a second. So if I want to evaluate this with a negative power, remember, negative powers flip where things are in fractions. So right now, 81 to the negative 3/4 is really 1 over 81 to the 3/4. The negative power flips where it is in a fraction. Well, the fourth root of 81, I'm really doing the fourth root of 81 to the third, all over 1. The fourth root of 81 is 3. 3 to the third is 27. All right, now you're thinking, how on earth am I supposed to know that? You don't have to know that. It's worth being able to figure that out, but I can do 81 to the, in my calculator, negative 3 divided by 4, that all in parentheses. It gives me that. Remember, I press this math button here. The first option is arrow-frac, 1 over 27. If I have a variable here I'm simplifying. On the first problem on the left, I was evaluating, because I can actually calculate 81 to negative 3/4, so that can calculate. Because I have this variable, I don't know what this is, but I want to simplify it. Simplifying means I can't have a negative power, and I can't have rational powers on the bottoms of fractions. For example, this becomes 1 over a to the 3/2. I dealt with that negative power. But I don't like having this thing here. I don't want to have a fraction power on the bottom of a fraction. I know that I'm going to be using the word fraction a lot now, so we have fractions and fractions with the powers of fractions. But I can't have that fraction power down there. So what I do, as I can always do, I multiply by 1. And when I multiply by 1, I'm picking a clever one that'll make this problem go away. Basically, I'm asking the question, what does this have to multiply by to make this a whole number? Well, 3/2 and 1/2 is 4/2, so I really get a squared. So I have a to the 1/2 over a squared. I want this power down here to be a whole number, so I have to make that happen. So if you think back to what we've learned in the past, a to the 3rd times a to the 5th becomes a to the 8th. I add those powers. Well, if I have something like 1 over a to the 2/3, I want to make this 2/3 a whole number, so I'm asking 2/3 plus what equals the next whole number, which is 1. Well, obviously 2/3 plus 1/3 is 1, so I want to add a 1/3 up there. Whatever I do to the bottom, I do to the top. So this would be a to the 1/3 over a to the 3/3, but a to the 3/3 is really 1, a to the 1st. So a to negative 2/3, I actually just did this problem, didn't I? It becomes 1 over a to the 2/3. I multiply the top and the bottom by a third, by a to the 1/3, excuse me, and I get a to the 1/3 over a. So b to the negative 7/5 becomes 1 over b to the 7/5. So I want to get rid of that fraction on the bottom. Right now, 1 and 7, or b to the 7/5 is over 1. 7/5 is really 1 and 2/5. So I'm going to make this go to the next whole number. So the question is 7/5 plus what becomes a whole number? Well, the whole number here would be 2, because 7/5 is bigger than 1, it's closer to 2. So I'm going to add 3/5 in here. And that becomes b to the 3/5 over b squared, because 10/5 equals 2. That's their simplified form where there's no negative powers and the fraction powers are at least on top on the denominator. Okay, just as I said before, we know that a squared times a equals a to the 3rd. We just add the powers, so x to the 2/3 times x to the 1/3 is really x to the 3/3, which is really just x. X to the 3/4 times 2, well, I'm doing 3 over 4 plus 2 over 1. I need a common denominator. So I'm really doing this, x to the 3/4 plus x to the 2 over 1. The common denominator is 4, so 3/4 plus 8/4 is 11/4. This becomes x to the 11/4. So I want to find a common denominator of 2/3 and 4/5. This is stuff you can do in your calculator, of course, but the common denominator here is 15. So 10/15 plus 12/15 becomes 22/15. So it's x to the 22/15. When you're multiplying, you just add. Powers, again, compared to a simpler problem, I know that x to the 3rd squared, I multiply that to become x to the 6th. So here I'm going to multiply also. This becomes x to the 2/3 times 2, which is x to the 4/3. I multiply across the top and the bottom. 2 times 2 is 4, 3 times 1 is 3. And this will become x to the 6/35, and this will become x to the 2/6, which can reduce to x to the 1/3. If you really want to check these, you certainly can. I plug a number in for x, like 2. 2 is the best one to plug in. If I do in parentheses 2 to the 2/3, double close that parenthesis, and then do that to the 1/2, I'm going to be checking this. Well, I see what that equals. That equals that decimal. Now if I do 2 to the 1/3, it equals the exact same decimal, so I know I've done this right. That's what you can check on your calculator if you want to. Okay, a little bit more complicated, but just more examples. Here I subtract those powers. A to the 3rd minus over a to the 2nd becomes a to the 1st on top. So here I'm going to subtract these also. I'm really doing b to the 1/2 minus 1/3. I again need a common denominator. So it's 3/6 minus 2/6. That becomes b to the 1/6. Since that's positive, that goes on top. So there's actually nothing on the bottom. The answer is just ab to the 1/6. Either this b to the negative 3 over 2 moves down to the bottom of the fraction because it has a negative power. I'll switch colors for this one. So this becomes a to the 8/3 over b to the 3.
Shayla Olson, please come to the front office. Shayla Olson.
Shayla, please go to the office. Now I can't have this fraction on the bottom, on the denominator, so I'm going to multiply both sides, top and bottom, by b to the 1/2, which will make this a whole number on the bottom, so I get a to the 8/3 b to the 1/2 over b to the 4/2, which is really just b squared, because this plus this becomes b to the 4/2, which becomes b squared down here. Basically, what I always recommend you do is compare to a simpler problem and convert between radical and exponential forms. So for example, if you see a problem like this and you have no idea what you're supposed to do, compare it to a simpler problem like this. Okay, here I know that I would subtract, I would do 3 minus 2 to get 1. Which tells me over here I know I'm going to subtract. I'm doing 2/3 minus 1/2. Well, that has to have a common denominator, and I get that that's tougher, but, you know, get over it. This becomes 4/6 minus 3/6 is x to the 1, which really means 6 root of x, if you want to think about it that way. I don't care how you write it. And if seeing something in radical form, makes you uneasy, if you're not sure how to handle this, you can put it in exponential form. This is the same as x to the 5/3 times x to the 3/4. Now I add those powers, so it's going to be x to the 5/3 plus 3/4. Get a common denominator, and that is 12. So 20/12 plus 9/12, and that's x to the 29 plus. Comparing to a simpler problem or converting between forms are the two best tricks for these problems. That covers everything. Thank you very much. Have a wonderful day.